Welcome to this video where we'll dive into one of the essential concepts in TypeScript, type parameters and their constraints. If you're working with TypeScript or planning to adopt it for your project, understanding how to work with generics and constraints is crucial for creating robust, reusable, and maintainable code. Today, we're going to explore a specific scenario that often puzzles developers when a type parameter might need an extends constraint in TypeScript. This concept is vital because it affects how you design and implement your interfaces, classes, and functions to ensure they are flexible yet safe. To begin with, let's briefly discuss what generics and type parameters are in the context of TypeScript. Generics allow us to create reusable components that can work with multiple types rather than a single type, making our code more versatile without sacrificing type safety. A type parameter is a placeholder for a specific type that will be specified when a generic is instantiated. Now, let's consider why we might need constraints on these type parameters. Sometimes you want to limit the possible types that can be used with your generics, ensuring they meet certain criteria or implement specific interfaces. This is where the extends keyword comes into play. Well, by using extends, you're telling TypeScript that any type passed as a type parameter must be compatible with, i.e. extend, the type you specify. A common use case for needing an extends constraint involves scenarios where your generic function or class needs to access properties or methods of a specific base type. For instance, if you have a generic function that sorts an array of objects, it would be beneficial to constrain the type parameter to ensure that any object passed in must at least implement a basic comparison interface. Imagine we're building a sorting algorithm that works with various types of data. Without constraints, we'd struggle to access properties necessary for comparison within our generic implementation. By adding an extends constraint, we can guarantee that our function only accepts types that have the necessary methods or properties for sorting, thus ensuring type safety and preventing potential runtime error. For example, consider a scenario where you're building a system that needs to work with different shapes, circles, squares, triangles, etc. If these shapes all implement an interface-like shape, which has a method getArea, you could constrain your type parameter to extend shape. This way, any shape passed into your generic function or class is guaranteed to have the getArea method. Generics and type parameters in TypeScript enable reusable code while maintaining type safety. The extends keyword is used to apply constraints on type parameters. Constraints are necessary when you need to ensure that a type parameter implements specific interfaces or inherits from certain base types, especially for accessing properties or methods within your generic implementation. In understanding when and how to use the extends constraint with type parameters in TypeScript is crucial for crafting robust, flexible, and maintainable code. By mastering this concept, you'll significantly improve your ability to write generics that are both versatile and safe. If you have any questions or need further clarification on using extends constraints, please don't hesitate to ask in the comments below. Don't forget to like this video if it helped you understand type parameters better, and consider subscribing for more content on TypeScript and software development best practices. Thanks for watching.